We are happy to see so many enthusiastic faces here. It's my immense pleasure to welcome our speaker of the day, Dr. R. Sarangan. He is currently working as a professor and head of the department in computer science and engineering in the Basic Multi-Day Tyagarajan Engineering College. He has completed his UG in Tyagarajan College of Engineering, Madurai affiliated to Kamaraj University, Madurai in the discipline of Electrical and Electronics Engineering in the year of 1994. Further, he has completed his PG in ME of Computer Engineering in Madurai Kamaraj University in 2000, and he has completed his doctorate degree in Information and Communication Engineering in Anna University, Chennai in 2010. He is having more than 25 years of academic and administrative experience in various engineering colleges. He is the recognized supervisor of Anna University, Chennai. 12 research scholars has successfully completed their doctoral degree under his guidance. He has published 35 journal papers in various international and national reputed journals. Now I request the professor to take over the session. So we welcome you, sir.
From our institution, and the faculty members of Electric and the convener of this FTP, Dr. Subhashini, and other leaders in this wonderful event. So, good morning to one and all. So, today I am here to share some of the aspects, especially I have experienced in the research of how the machine learning is used for wind power prediction. So one thing I want to share is, today everything is multidisciplinary. Whatever the application you have developed, even you have used for AI, to the context of this technique. So this AI technique is used in various sectors, start with mechanical to all the sectors, healthcare and everywhere. So understanding the multidisciplinary field is very, very essential. Luckily, I have completed my UG in electrical and electronics engineering, and I have got industrial experience more than 5 years. So I have been in transmission and distribution sector, and then industrial sectors also. So I can easily understand how we are going to use these algorithms in which way. So that is the thing. So that is the first motivation. So why I am choosing this one. So I have done this one for the lead being, they are one of the company, they are doing data analytics, okay, and even they are having 900 megawatts wind power prediction, wind power generation. They are having their own wind power production, okay. Apart from that, they are doing the wind energy forecasting for tangent code. The tangent code is nothing but Tamil Nadu government electricity. It's a tangent code. So they are doing prediction of wind energy. So the prediction is very, very important because the wind is freely available in nature. Okay, and the wind generator, you could see the wind generator in the area of Kanyakumari area, some of the area. So there are 3 to 4 areas in Tamil Nadu. So near Kanyakumari. So there we are having number of wind turbine. So that is the reason I want to tell you. And another one is compound well, commonly known the Kenny district. And another one is near Rovundur. So here the western part is separated. Tamil So the wind is clean energy. Operation cost is very less. It is a free of source. So only the installation cost is there, whatever the cost of wind and turbine. Okay, but the maintenance cost and everything is zero. The maintenance is producing energy, but actual maintenance is also there. So the cost is very less. So here the motivation is in the power produced by the wind, as far as maximum we can use it. If we use it, the wind energy in more contribution, then we can reduce the idle energy or any fossil fuel based energy, for example thermal energy. Because fossil based required, anytime we can do it. But as far as we are using the wind energy as it is, because wind is seasonal and it is highly intermittent, so we can't predict the wind speed. Every time that will change, and you can easily understand the power of the prediction, because how they have predicted the Bengal storm. Okay, prediction now it has become a mature one. I will tell you. So prediction of wind energy is a great task. If you predict it, what will happen? Say example, the total energy consumption of Tamil Nadu is nearly 15,000 megawatt. Okay. So out of 15,000, we are going to compensate various energy produced, atomic energy, tidal energy, even renewable energy. I will talk about renewable energy. So let us consider 5,000 megawatt is compensated with the wind energy. So wind energy we are giving more priority. Okay. So we can shut down the other power sources, because other power sources we can use it at any time. But wind energy, it is a critical thing. We have to use it whenever it is available. Okay. So if you give more concentration of wind energy, use of wind energy, then the cost is very less. But prediction of wind energy is very difficult. If you predict it tomorrow, we are going to produce 5,000 megawatt. Let us consider. So out of 15,000, only 10,000 is produced by other sources. That 5,000 may be allotted for wind energy. If you predict correctly, any 5 to 10% deviation. So instead of 5,000, 4,000 megawatt is produced, we can manage. Or 5,100 or 5,100 is produced, we can manage. So due to sudden effect of wind, the wind production is 1,000 megawatt. 5,000 megawatt. Again, there is a power crisis. So we have planned for 15,000. We are expecting 5,000 from a wind source. Right? If the prediction is good, then 5 to 10% deviation is allowed there. Even if you predicted 5,000 but produce only 1,000, then how we are going to compensate the remaining 4,000? There is a power cut. Because whatever the other power sources, immediately we can't do it. If it is atomic or if it is a thermal power station, we can load it, it will take time. So that's the thing. So that's what predicting wind power is very essential. And again, I want to share some of the statistics. Why I am telling, producing renewable energy, it is come under the Ministry of New and Renewable Energy. Because there is a separate Ministry of New and Renewable Energy. So that ministry is concentrating on various renewable energy sources. So the renewable energy, it is the concentration of most of the countries. Because fossil fuel, it is one day it is going to be extinct. So there is no coal or there is no petrol over there. Even we are taking petrol or coal, and again it will create a serious environmental risk. So that's what people are concentrating other sources, alternate energy. So like renewable energy, solar, wind, people are going for hydrogen-based energy. Right? And then you know that EV vehicles nowadays, the terrain itself. Even it has been installed in the deep sea also. So they have collected wind speed, prediction, humidity and all things, and they try to predict the weather conditions. So here if you go for www.indica, this is one of the website that they have shown a lot of weather forecasting models there. Mostly we are considering for our application US based model. So here the weather forecasting model, if you select any one of the region of India, then you can get the data for the next 7 days. What is the temperature and what is the wind speed? Next 7 days, right? You will predict it. So they are having all the models. So here how they are doing it, they are having computers for doing computation and they try to predict it. Even with the help of satellites, they will get the data as well as previous data also. Because we are having historical data. So the weather forecasting is one of the notable application of big data applications. Weather forecasting itself is a big area. And forecasting weather is very difficult and they are using very complex model also. With the use of a lot of development in hardware technology. Now we are having powerful systems as well as processing speed. Then we can predict the wind and we can predict the weather with good accuracy, 90%. And even you could see that we can predict the weather next 3 hours there is a rain in some of the. So they predict it correctly. So the prediction is very, very difficult because they are having a huge volume of data. Next 5 years of it. Day-to-day data. 24 hours they are collecting the data. So the weather forecasting station they have installed there, all the sensors are deployed. So it is a big application area of IoT. I will come to the part where IoT is used. So that's not renewable energy. They have invited proposals from wind energy forecasting. And they have Gujarat, they have floated this solar panel in Sabarmati river, and offshore storage. India targets to have installed a high capacity 170 gigawatts by 2025, and it may be raised to 500 gigawatts. So these are all the statistics. So clearly we know that what is the scope of energy, what is the scope of renewable energy, which is going to replace very soon all thermal power stations. Money may be there, but thermal idle we couldn't expect that, because if it is a rain, then we can produce energy through idle. But all the time, again, we go back solar energy, wind energy. So here, wind energy is one of the renewable energy source. It is one of the energy source in India. It is abundantly available in India. Generation of electrical power through wind energy is very clean, less environmental source. Almost there is no pollution. The main source of wind in South Tamil Nadu is supplying from southeast monsoon. So this season may be started in June and it is existing up to October. This season is between May to September. The wind is alternating, so I have to the tunneling effect, and due to the tunneling effect, so what are the challenges in wind energy? So the cost reduction and the indigenization of wind turbine components and subsystems, the development of materials, techniques, technologies for offshore renewable energy requirement. Because most of the European countries, they have installed wind turbine in terrain as well as seashore, offshore, both places. Okay? Even I have read a news, they have produced excess power. Excess power, there is no way to use that energy. They are producing excess power through wind energy. Okay? So, but India, definitely we are lacking of power generation. And then modeling and simulation including high performance computing, because this leads to prediction of wind energy, leads to high performance computing, because we have to consider a number of parameters for prediction of wind. Predicting wind is very good. And so if you predict the wind correctly, then we can easily predict the generation, wind power generation, and we can easily do the forecast. And we can do a performance analysis also. I already told you that scenario 5,000 is expected to be produced in next day. Then we can shut down all the power stations, and we can give more importance to wind generation. If it is correct, your prediction is correct, we can save a lot of money, because it has been obtained from the mines of Indonesia. Most of the thermal stations in Tamil Nadu, they have obtained coal from Indonesian mines. Navy, of course, they have to some extent they are satisfied, but not fully. So producing power through coal, again, it is a difficult process. That coal is obtained from Indonesia, coming to ships, and there is a yard. That yard is going to be used for storage of coal. Okay, and then again there is a supply chain process. If you start 1 month of coal, then you can do it. Right? So 1 month it will take next 1 month you can fill it from Indonesia to here. So if you start with 2 months coal, then you need more storage. There is a possibility of fire. So a lot of production is required. So that's what it is a different area. So it will call it as a supply chain. So, but if you store less than 1 month coal, then there is a power cut. So we have to do optimization. Right? So that is one of the area. So here the lidar installation and horizontal or vertical axis turbine. So the wind, you could see the wind turbine in Romalpet area and Caroline. that field is started in 1940s. Okay. Turing test. You understand what is Turing test? You could study Turing test. What is Turing test? Alan Turing is famous scientist. He has conducted a test. Turing test. What is that? So it is very simple. So there is a hindrance. Wow. Okay. Both sides, two humans are sitting. Okay. They try to interact. Okay. Both are human beings. So one person is timing what's her name. Other side, they can my name is Suresh. Right. This person understands it. And then he types what's your name our way. Then he types it. My name is Manoj. Okay. So both ways the communication is happening. So what are the things is required for this application? Both are human beings, both are learned natural language like English or any other common language. So they would understand what is the question being asked. And they should know what is the answer. Okay. So what are the areas are related? One is natural language processing. So human itself, we can process the natural language. We can interpret English. We can understand what has been processed. And we know that what is the answer. So that's what the communication is going on. Okay? Both sides human being. Okay. Right. We need a natural language processing. And then knowledge representation. Because that knowledge is represented. Okay? How the knowledge is represented? How the knowledge is stored in our brain. Do you understand? Is there any mathematics for storing and retrieving? Because storing and retrieving, we are having softwares. Databases are used for storing the data and retrieving the data. But how do we store the data in our brain? How it is retrieved? And brain, the power is very tremendous. It can understand formatted or unformatted data also. It can understand the image. It can understand the motion of the video. Everything is stored in our brain. But data processing, we can store a structured data. For audio mostly, it will support structured data, table-oriented data. But nowadays, based on the recent technology, people are going for unstructured data, like NoSQL. Right? Because NoSQL, most of the applications is require unstructured data. But your human brain support two types of data, structured as well as unstructured. Even image processing, whatever the things you do. So knowledge representation is required, and then natural language processing is required. So you can have any. So I am telling, suppose that conversation going for any novel. Both persons are aware about that area, so they are only they can interact. The discussion going with any sports team. Okay, so who is the winner of the first test in Australia? Me. So like that. So a knowledge should be stored, and whatever the question being asked from outside other side, then this person can interpret correctly and checking with the knowledge base available with the human being, and he is going to do. So that's what a knowledge representation is required and a natural process is required. So for typing and all, okay, we need dynamics, chromatics. We are having fingers, right? We need dynamics. As well as seeing the screen, we can easily visualize. So here, the Turing test is, we are going to replace human being one side with the user machine. So that machine, it is going to interact with you and it will give some extent second advantage. So these logics are very limited, but our brain is unlimited. So if you store the knowledge for a robot, you are going to replace yourself with a machine. Then definitely, if you are asking the questions from a source, human can understand. He is doing all. But the thing is, how we are going to store the data in the machine. And suppose one question is being asked, then we can expect the machine is give a correct answer. Definitely we need knowledge. And then we are having eyes, but on the other side, computer vision is important. We are having hand. Other side, you have to give a dynamics, robotics. So the Turing test is a machine. As of now, machine can defeat. No. So that's what it is a Turing test. Okay? So still, as of now, even we are having very sophisticated computation and sophisticated analyzing method. To some areas, machines are excelling. Machines are excelling in comparison to human beings, but cannot defeat entirely human being. One day it is going to defeat a human being, then everything is going to be machine. Okay? So the Turing test is failed until now. Okay? So that's not coming to the significance of AI. Okay? Up to 2010, what is the evolution of internet? Because internet is very powerful. We used to connect all the peoples all over the world. Okay? So when the internet is introduced, you are aware about it. However, when the internet is introduced, 1980s, Java network that has been used by US governments and it was come to use for people 1990s, because before 1990s connecting machine is very difficult and there is no broad connectivity. So for that they used to they used a number of softwares like Java. Yes, 1990 Java is used. Java is the first data cross banking, banking to bank, introduced, and then ATM is introduced. Okay, later ATM is introduced. Now banking itself is a mature technology. They are mature. All the areas have been matured. So many applications are developed. These are applications. This scenario is after 2010. After 2010, how it has been done. So after 2010, they are having a successful internet protocols. They are having an internet architecture. You know that 7 layer, start with 7 layer, application and physical layer. Sometimes it may be 5 layers. Session and presentation is optional. So the 5 layers is very important. Or it is a piece build. What is the protocol used in internet network layer? IP version 4. IP version 4 is used. IP version 4 is strictly designed for fixed network. Fixed network, we can configure IP address for all the fixed systems. It is not possible for moving this system. Now once configured, all IP addresses are assigned. Later, okay. So people are configuring database administration of the work is configured. So later, again, there is a parallel development of the mobile phone. So actually, internet as well as mobile phone both are parallel. 1990s, first mobile phones and the ASL is introduced. The ASL is designed for voice communication. First, it is designed only for voice and telephone applications. So again, there is a parallel development there. Telephone application where people are used to send a data communication from each other. So data communication for one point, both are merged. Your mobile as well as data. Internet is developed there as well as mobile is developed there. Now mobile phones are not only used for telephone application, we can access the data through mobile. So mobile is now developed. So accessing internet through mobile, that application is steadily developed. Okay, both technologies merge. So now we are allowing mobility of data. But what we have designed, the original protocols, everything is designed for fixed system. Now mobility is introduced because your mobile phone is now enhanced for accessing internet also. So definitely your mobile itself is a system or phone, allowing mobility of data. Mobility of data, whatever the protocols are existingly used, IP version 4, it is designed for fixed system. So how people are managing? So at that time, some patchwork is done with the IP version 4. Okay. Later, IP version 4 or 32 bit. That is a bit of right? It is very limited. So how many IP addresses we can generate this to be about 30. So that much of IP address is generated. So that's what any. So for example, our college one IP address is assigned. Okay. So now what will happen? Due to the support of mobility of node, they are introducing IP version 6. IP version 6 is 128 bit. So that IP version 6 it supports mobility. So whenever they have introduced IP version 6, the entire scenario of internet is changed. This happened after 2010. People are using the word Internet of Things after 2010. So algorithm, mature technology is a client-server networking. Then after 2010, people are using the word Internet of Things by Industry 4 then we talked about. So what will happen? Now machines can connect with internet. Then what is the advantages of machines can connect with internet? Machine can communicate. What is the use again?
Improve the productivity.
So here a machine is connected with the internet. Let us consider a automatic machine in automobile industry. Automobile industry, you have seen this machine. A car is the car or that frame comes, and the machine is it will fix all the doors. You can see the process in the unique videos. So a simple machine itself where it will do all of this. It has robotic movement there. It will fix some of the things. It is wonderful. So if you do all the process with machines, this is one process in automobiles. If you consider in a textile industry, there is a machine called autocommander. Now why I am telling, because I have been working in the industry also, that autocommander, the end product of spinning mill is thread. Thread is the source for all the parts. After that weaving, we have made it as a cloth. Okay. So the thread is the end product of spinning mill. And what is the input of the spinning mill is the raw cotton. Raw cotton is the input. And raw cotton, they have produced threads. That department is called binding. The end product is thread. The thread is finished in terms of combs. So the thread is fine grained, and they are fixing a dia, for example 2 mm or 3 mm dia. Okay, so that it should be uniformly 2 to 3 mm. So then only it is perfect finishing. For example, due to the any malfunctioning of machine, that 2 mm dia, 3 mm dia, maybe some places some flinches is there. Sariya thread in the high speed they are making spinning and make all the cotton into fine grained thread. So that spinning operation is not properly done. There is a fringes thread. Some places the diameter high, 3 mm or 5 mm. So they are checking the quality of control. At that place they used to cut the thread. That marked portion is removed. Once again the thread is tied up for making uniformity dia of the thread. So it is the end product. So here that binding machine, previously people are used the machine on the electronic machine is there. The electronic machine. So at that time the people from Gujarat they have made a machine. The machine in the side of the poles. So the thread is passed in between the poles. So there is any extra projection in the thread. Immediately it will identify that the electronic circuit there is a cutter is involved. It will make a cut after cut. Then thread will be disconnected. Right. So one slider, they can call it a slider. They are moving and they will check it and they will put a knot. The knot also they are having a machine. So they used to put a knot. Then again it is running. So that the end product is the product is cone shaped. They have winded all the things. So later that human being is replaced with that machine, autocommander. That machinery is having developed in 1992 itself. That time only I worked in the textile industry because textile industry is mature technology at that time also. Both the use of can sit in a place. You can employ a lot of, you can deploy sensors in various parts of the machine. I will give a very good example. Car is the machine. Car is a wonderful thing. Nowadays, the car is fully automatic. Start with the measuring of the engine speed, what is the cooling temperature of the engine, all the AC or whatever the operation of the car, everything is controlled by a microcontroller. Everything is controlled. More than 100 sensors is being used in the car. Start with measuring the tire pressure and what is the suspension rate and what is the cooling temperature of the oil, cooling temperature of the water. Everything, what is the AC temperature inside the cabin, everything is measured. It is like a cockpit, and all the things are measured with the use of embedded systems. Embedded microcontroller is used. Right? Now the car is get connected with the internet. You could see the MG car, internet inside the program. So the MG, what is an garage? So now the car is get connected with the internet. What will happen? You can sit in a place and you can collect the data of the car. Car is moving. If it is moving for a good way, then the data is going to extract when it has been started and what is the temperature. And then you can get the data of all the sensors. All the sensor data are updated and these data are stored in the cloud. So if you are moving for a trip 200 kilometers for 4 hours, the 4 hours it is moving, then all the data are connected to sensors and it is stored in a cloud. Then what is the use of that data? It is a deluge of data. So here, that data we can measure the temperature, what is the temperature, pressure, and everything we can measure. If it is a normal operation of a car, then the parameters are not changed. Mostly depends. Temperature level, pressure level, because the car is running very smoothly. Suddenly something is happening in the car. Temperature cooling oil will be much. Then definitely immediately the inside temperature of the engine may be raised. Raise immediately we can make an arrangement, we can get an alert message. That is possible. And then the car is malfunctioning some durations. When it is hot, malfunctioning, what is the reason? Everything is granularly analyzed. Granularly analyzed. You can sit it and you can analyze the entire operation of the car. That is the power of today. That is the power of Internet of Things today. The same thing is extended to any machineries in industry. It is a powerful machine. Okay? That machine is running 24/7 and we are deploying number of sensors for that machine for smooth operation. We will get a continuous reading from a sensor. Then all the operations goes normally and you can easily measure the data. If you can easily observe the data, some data goes abnormal, then you can easily understand by analyzing the pattern of the data. If you can create a pattern for a good operation, you can create a pattern. Something is malfunctioning, you can easily identify the outperforming data. If it is identified outperforming, then you can understand what is the reason of outperforming. Okay, you can do preventive maintenance. The same thing is extended for any machines. There is a scanner in a healthcare. The scanner is connected with the internet and we are collecting all the data for the operation scanner and all the data is stored. We are having a accumulation of data. So here, coming to the picture, we are using AI techniques now. So now I will explain what is the data analytics. We are collecting a data The weather forecasting station is installed in a deep ocean. Right? That weather forecasting, that deep ocean of the floating station installed. And deep sea level, what is the temperature inside the sea? What is the pressure? What is the humidity level? And what is the seismographic movement under sea? Everything is measured by a weather forecasting station. That data is pushed to the current, and they are having edge computing and the demand. What is the meaning of edge computing? So that concept is famous now. Edge computing. Okay. So deep sea level, we can collect all the temperature related data, and these data are stored continuously, and we are going to prove a normal behavior. So if it is, there is no storm, there is no sudden change, then the temperature behavior is normal. Humidity is to some extent, temperature is to some extent. It is a normal day. Definitely a low pressure is there. The parameters have changed. Now the data are collected 24/7. We can get the data by any cyclic interval, 5 minutes once, 15 minutes once. We can determine the cycle. So 15 minutes once per day, 1 hour more reading. 24 hours pure, 24 into 96 reading. So you can take a reading of 96 reading per day. So like that you can extend per month, per year. So you are having all the data, normal operation. All the data is stored. You are having all data. It is accumulation of data. Then what you are going to do the data? You are going to do data analytics. So what are the normal behavior and temperature? If you fix a temperature limit within this limit, 20 degree to 24 degree is normal, 27 normal, but below than 20 is abnormal. You can easily separate the outperforming data. So by this way you can try to find out the outperforming nature. If it is outperforming, then what is the back factor? So the data are stored for the next 5 years, the previous 5 years. Now you can compare. So what is the normal behavior of data? Something goes abnormal, then what is the parameter at that time? So now the same thing is compared now. So you can easily predict it. Next 2 to 3 days there is a storm. So by this way, with the power of Internet of Things, you can analyze all the operations. Slowly they have been replaced by so many people. Healthcare, automobilist already is there. So that edge computing is also there. Okay, edge computing, whatever the data is processed within the application, nearby application. So in order to increase the speed, let us consider there is a car race. The cars are moving at a high speed in a lap, more than the cars, attracted cars. So we are closely observe all the parameters of the car, and we are having an edge computing near the track itself. All the data of the car. So here we need certain things to collect the data from the sensor, process it, and it is collected with the nearby collection unit. And we need communication protocol also. So that's what it is IoT. So the same thing for wind prediction also we are using. The paradigm is changed after the introduction of IoT. IoT is very powerful nowadays. Next, again, if you imagine IoT is being used in all applications, we are having a deluge of data, huge volume of data we can collect it from any applications. What we are going to do it? We are using intelligence. That's what the artificial intelligence people are using in many applications. That artificial intelligence, it has source to other useful prediction where from various perspectives models, such as ECM, WGFS, and ICO models. Because these models are used throughout the world. So out of this, the ECM, WGFS
this is our functional model for multiple inference. The features of inference generation of this field. Features session. Mainly the wind speed is varies mostly with respect to CC. That is the inference. Right? Day of the year, week of the year, it has a very low significance, but mostly the wind speed is very with respect to season. So the project is designed for Ministry of Renewable Resources, and it is covered in the MOU signed. So you have signed the MOU also. And the MOU is nothing but they can share the data for our institution. So we are doing an analysis and we will give a prediction model. So we will give a prediction. So based on our model, we will give a prediction. They are having their own model, they are doing prediction. So by comparing the lead green prediction with our prediction also. To some extent, our prediction is excelling. Because they used to predict some manual approach and they are having their own method. What we have used to do our machine learning method. So it excels in some aspects. Okay? And comparing to the lead green model. This lead green, they are having 850 megawatts installed capacity of data. All over the country. They are providing predictions and holding. So initially the standard data belongs to, so whatever we have received the data, it belongs to another village. They have mentioned like that. And this region is consisting of 19 machines mostly, each machine capacity of 1,500 kilowatts, and the SCADA is obtained, time slot is 15 minutes. And most work uses Apache server for hosting the web application. PHP with MongoDB is used because MongoDB does a non-SQL DB and unstructured data and very useful for SQL and unstructured data. And this is Java is used for observational logic, data analysis, Python models of Pandas, coders, and MongoDB, math, and this is set up in it. So it is very risk application, but we use our purpose of code as so here we are combining two methodologies. That's what it is considered as a hybrid model. So one is SCADA data. The SCADA data is a PEC data. We are having historical data. So below this is historical data. And another one is field data streaming. It is a real-time data obtained from the field. So both data are compared based on this. So we are already having historical data. The historical data is compared with the data as of now. Then we will predict the results. So based on this approach, we will do whether window speed. So finally, the output of this work is we have proposed wind speed, and we are comparing the wind speed, proposed wind speed, and comparing with the proposed wind speed of lead green. So this thing we have compared. So well-integrated forecasting as well as lead green process. So they are considering different machines. There are 19 machines. So totally less than 1 deviation we are having. So the data is not visible. But we are excelling to some extent. Some machines we are excelling, and some other machines they are excelling. So by this way, the prediction is happened. prediction 2 will be 16. So in total they are having that much of deviation. Our prediction is not your prediction. That is the difference. Because here this is clearly visible. The forecast chart with comparison, proposed method, the well that we are performing, it outperforms the lead green technique in terms of absolute error calculation. For example, lead green, they are having the absolute error. Their wind speed prediction, absolute error is 28% or less than equal to 10% variation. But we are having 18% absolute variation. Whatever the wind speed we have predicted is mostly their deviation is 28, but our deviation is 28. So that's what we are closely predict the wind speed. That's clear. And the deviation is measured in terms of the percentage. 10%, for example, if it is wind speed is 10, 10 is 1 meter per second, maybe 9 or 11. That is the deviation. That deviation mostly on the 18% in our case, but they are having 20%. By this way, so the deviation is measured. So there are 96 hours every day. They are taking. So to some extent, at 10 to 20% deviation, again, makes a difference. So something lead green is excelling and some other aspect we are excelling. So again, this is a continuous process, and we have changed some parameters in the execution algorithm, and they try to align with the window prediction. If the window prediction accuracy is increased, for example 80% is 90%, 90 is 90 plus, by this way, if we predict the wind speed mostly 90 plus percentage, then you will get the figure of what power it is going to store, it is going to generate. So based on that, you will get the power prediction also. So once you have predicted well, then the prediction result is given to the EV. So they are rescheduling the power. As per the prediction, if the power generation is happened, then it is most likely is a success of an application. So we are saving number of money also. Because if you try to use an EV with high priority, then probably shut down other sources, thermal or something. But ideally, suppose we are having abundant of EV power, wind power, so we try to use wind power as it is. Then we can store the water. Ideally, we can stop it. So whatever there is no wind, then we can use idle or some other thermal power. So we will give a first priority to wind power. Because wind power is at the end of the day, we are going to calculate what is the cost per unit. If it is a thermal power station, then cost per unit, for example, for the selling price, what is the unit cost? They are increasing different slab, 4 rupees, 10 rupees per unit or something. Okay? But what is the cost per unit? They are providing EV, wind power, EV only 4 rupees. But they are selling to us 12 rupees and 9 rupees. But they are putting only 4 rupees. If it is a thermal, maybe 6 rupees per unit. Cost per unit, 6 rupees per unit. For EV, through wind power, 4 rupees per unit. Very cheap. So here the wind deviation meter per second less than 1 meter per second. Lead green, they have predicted 25%, and we are having 30%. And some cases, so mostly we are reaching because legally they are having a practical method, they are having industry for more than 10 years. So we have started our work only the 2 months or 3 months, and we are achieving mostly whatever the prediction by legally, we are also doing the same. And this is a sensor appearance. Front end we have designed. So here the live wind speed is displayed. And what is the live power is generated, everything is displayed, and there is a graph analysis. It is compared to the prediction, both weekly and outside. So by this way, it is the same. So here we have analyzed number of sensors are used. For example, we are using these sensors for collecting images. With respect to the time delay we have considered. For example, the data is stored in multiple servers. The data are updated from multiple clients. The client is more. The client is more. For example, 50 clients in group is less. More number of clients in the group is less. So that is the inference. So the same thing, if you use multiple server, then the group is increased. So this is a continuous research. We have to analyze the wind speed prediction. Right? If the prediction is good, then still we have to improve the prediction. More than 90%, 92, 93, and so on. It is an experimental process. We have to consider the whatever the wind speed prediction obtained from our method. So we have to do fine tuning by changing the parameters. So which will give an impact after the prediction in program. So like that, if you increase the prediction success rate more than 90%, so definitely we will settle down in our good prediction model. For that we have to alter the parameters of the our parameters. Which parameter is mostly influencing the wind speed? I already told you wind density. The wind density we are considering because based on the wind density, the power generation is proportional. If the wind is high density, then it will produce more power. That is also one conclusion. Not only wind speed with density, then it will produce more power. Any questions? Any doubt? How many are doing research in this area? Bench processing is one of the area. And how many are doing research? I am doing research. So here my concentration of research as of now is I am doing one project and study of data center infrastructure in India. they used to develop standards for data centers because there is no standard to follow in data centers. People are following their own data standard. There is no Indian context data centers because Indian context standards say B is as to it. So that's what they have announced. And I have analyzed and a lot of scope is there, but it should be a multidisciplinary. So you can separate it into categories. This power related. All the time there is a study happening how to improve the power usage efficiency data center. Because power usage efficiency is very important. Some power is used for IT equipment. So definitely upkeeping the server they require some power. Right? So that power may be supplied to the IT server which is used to work. And some power may be used for cooling the server. Because cooling itself is very, very important. All the time the server is working, it produces a lot of heat. 24 hours it is working. What is a server with a capacity of kilowatts? Rack, they are installing different rack. Each rack only 5 kilowatt, 10 kilowatt. So if you use multiple rack like that, then the capacity of data center will be 100 kilowatts. Like that. So if you use that infrastructure, then definitely more power is used. So a particular amount of energy is used to cool the equipment. Cooling itself what are the cooling techniques they have used. So IT infrastructure what are the power efficient method for power consumption, reducing power consumption of infrastructure, and what are the storage units they have used. And it's in a cloud they are having computation load as well as storage load. Computation is also performed in data center like the AI related computations, everything. So if you do computation, then what are the machine structure they are using, then how much of it they will produce. And this processed data again stored in a server. So server itself is storing in the tray and it requires a lot of and cooling is required and what are the cooling factor. And then I already told you a significant power is used for cooling the server. So ultimately they are using liquid cooling technology and chiller unit they are used. Chiller unit. This is one aspect, and what are the other powers is diverted for functioning of data center. For example, lighting load or other necessary things. So they are used to calculate the power usage effectiveness in terms of power. Consume power for IT infrastructure. Definitely server requires some power. So then only you will upkeep it. Not only IT infrastructure, cooling and other aspects we require. So totally what is the power is consumed by an IT infrastructure divided by the total power consumed by the data center. So that is PUE. So all the time they try to reduce PUE in very good rate. So then only that data center is an efficient data center. Or otherwise if we use more power for cooling other applications, so it consumes more power all the time. So definitely steady power is required for output. So EV is a main source, and I already told you PUE is one of the factors. And if you are using more power, water usage is very important. You understand what is water usage effectiveness? Water usage effectiveness. The water usage effectiveness if you I did a program. They have calculated water usage effectiveness for a cup of coffee. How much water in a cup of coffee? Because water usage is very important. I just shared some of these. What is the cup of coffee? How much of water is there? 300 So by this way they are calculating entire water usage. So now what is the effective water usage for making a cup of coffee? 150 liters. That's it. Okay? You understand what is water usage? So like that 150 liters may be used for making 100 ml or 200 ml cup of coffee. In India, they are encouraged industrialization. Most of the countries, even Kerala, they won't allow most of the industries. They won't allow to disturb their environment. So here, if Tamil Nadu itself, they encourage to start a new industry, industries. So each and every industry is related to usage of water. Whatever industry, it is a leather factory. Huge volume of water is used for washing, make it the shoes is not shoes 1,000.
Chinese, as usual, they won't reveal it. they used to develop or any application, visualization data are used. So the visualization effect is measured with the capacity of data centers. So here the statistics is 90% of a government application, everything is converted into visualization. Visualize 90% of data. But what is the effective usage of digital data is 30%. People try to use more number of digital data and definitely we require a huge amount of data. Now, how many we used to access data through mobile? Still, in the lay persons in a village, they are not trained. Okay. They try to use more digital data, definitely prepare more data sets. So that is the prediction. With that, there is a huge improvement in data centers. So data centers improve then it requires more power. So I told you 3% of the entire nation power generation is consumed by data centers. The 3% maybe 10% power. So what is the thing is they used to develop this sustainable development. The sustainable development they try to use electrical power through renewable energies. So any data centers, even Google, do you understand what is the use of data centers? Suppose YouTube is a huge organization, okay? And they are having lakhs and lakhs of videos. Everything is stored in a server, in a digitized form. So what is you just assume that what is their structure, where they are using, how many data centers they are having, because the devices itself they are having their own data centers. Like Amazon, they are having their own data centers. Google, Microsoft. They have uploaded the power to grid and they are taking power in another area. Data centers, where they are having data centers, they are consuming power because they are having data centers in Chennai, data centers there. Adani, they are having data centers. Adani, they have produced power in Ramnavati with the solar park. They have uploaded energy into the grid. They are consuming energy here, Chennai. So by this way, in future, the data centers are encouraged for doing sustainable activities, usage of renewable power mostly, in order to reduce the CUE and the WUE. If it is power generated through thermal, then definitely there is water usage. Thermal energy itself, whatever the process you are doing, definitely there is a significant amount of water is used. They try to avoid the water usage. That much of awareness people are having now. Any doubt? With this, I have concluded my session. So this is one of the interesting areas, okay, prediction. And as I told you, I have chosen multidisciplinary subject. The power of computer science is realized whenever it is used in real-time applications, like weather forecasting, data analytics for an industry. As industry, even industry core, everything is digitized, and whatever the analytics, everything is done through systems. So they are given a chart, forecasting everything. Even they are doing preventive maintenance. Suppose one machine is outperforming, they have analyzed all the historical data of a machine. So you are having high use of data related to machine. The when it is outperforming, what is the reason for outperforming? Why the failure is happening? Everything is analyzed. And in future, what is the reason for failure? If you consider Boeing 380, it is a huge, nearly 10,000 plus sensors are used in flight. That sensors all the time it measures all the parameters of a engine, flight engine. So it is used to collect in the cloud itself, and since we are having a huge volume of data, we can separate all the data like that. For a jet engine, These are all possible after the development of the
Many
So, like
sensors are costly, sir. Actually, many sensors are costly.
custom.
On the
The sensors, again, if you say that not costly, it is a bottleneck. If you get the exact data, then the sensor technology will be successful one. So if you measure the temperature per room, you will get a close data. It is accuracy of sensor. Then based on that only you are going to do it. So which doctor today they are going to analyze the patient now? Whether they are checking the patient by physical checking? No. They mostly depends on reports, ultrasonic reports and all. If the device give a wrong report, they are going to give a wrong treatment also. So that's what soon the doctors are going to give this. So that is the power of AI technology. Doctors are going to give this very soon. So mostly all the doctors are depends on that report. Ultrasonic and MR. Based on that only they are giving treatment. They are giving treatment. Blood sample. How many, which doctor they are going to check the kind of conditions. They depends on the report. Blood test, pressure, sugar, and then scanning report. Based on that only they are predicting. So that thing machine learning is good in comparison to even expert. So with this